Okay, today we will study how to derive sigma k squared and sigma k cubed. To derive sigma k squared, we use this technique. N plus 1 cube minus n cube, you multiply out and simplify, then it will be 3n squared plus 3n plus 1. When you multiply out here, you have n to the power, but you subtract with that. Finally, you have only 3n squared plus 3n plus 1 here. Okay? It's very important uses. Okay? Using this formula, we replace the value of n by n minus 1 and n minus 2 and n minus 3 all the way down up to we get 1. Okay? Okay, you can see that relation over here. You replace n by n minus 1. This one come out n minus 1 cube, n minus 2, all the way down up to 3 cube, 2 cube, and 1. And here, if you replace n by n minus 1, then n minus 1 plus 1 will be n. And the next step, if you replace n by n minus 2 plus 1 will be n minus 1. So you can see the pattern all the way up to down 1. Because this one, if you compare here, this is 1 more than that. So you have 1 more than this. And from equal, on right side, you have 3 times n squared plus 3n plus 1. And we replace n by n minus 1, n minus 2, all the way down up to 1. And here also, n minus 1, n minus 2, all the way down to 1. But here you don't have any n to replace, so you just repeat writing plus 1, plus 1, plus 1, plus 1. So on left side, this one, you can see here, this one and that one cancel. Exactly same one you can cancel. Exactly same one you can cancel. Exactly same one you can cancel. Eventually you have a n plus 1 cube minus 1. n plus 1 cube minus 1. Okay? On left side, all of them canceled out, you have only this one. And then right side you can see here. On this column, you have 3 times 1 squared, 3 times 2 squared, 3 times 3 squared, all the way up to n. So with the sigma notation, we can say 3 times k squared as value of k go from 1 to n. Okay? And you can see here, square, square, square. So we just replace k. And then here you also have 3 times 1, 2, 3, all the way up to n. So you add them all vertically, right? So this one 3 times sigma k. And then here you don't have any k to use sigma. That's why you have how many plus 1 plus 1? You have n of them, okay? Now, this one remain here, but this one we studied the formula from last lecture already, so you can replace. Sigma k was what? 1 times n plus 1 divided by 2. Now you look at here. Only sigma k squared is a known value. So you leave only this one side and move all the other one the other side, and then so for sigma say k squared, sigma k squared. Because our purpose is that, right? Now, if you solve for sigma k squared and moving all terms to one side and simplify, then we get the sigma k squared is n times n plus 1 times 2n plus 1 divided by 6. Okay? N times 1 plus n times 1 plus 2n divided by 6. This one is a calculation formula for sigma k squared. Now we try to get sigma k cube. Okay? Sigma k cube. Now you look at here, k cube means the third power, and then we use one higher power with the same expression. Okay? And then right side, if you simplify that, it turns out this one. We have only those terms left. Okay? And again, exactly the same. You just replace the value of n by n minus 1, and then n minus 2, and then n minus 3 all the way down to 1. Then, on left side, as we saw the case of a k squared, this one and that one same cancel, same one cancel, same one cancel, same one cancel. Eventually we have n plus 1 to the 4th power minus 1 to the 4th. And the right side, now you look at here, times 5, 4 times 1 cube, 4 times 2 cube, 4 times 3 cube, all the way up to n, which means what? Using definition of a sigma notation, we have a 4 times sigma k cube with the value of k 1 through n. And again here you have a 6. Now 1 squared, 2 squared, 3 squared, so you will be sigma k squared. And then we have 4 times 1, 4 times 2, 4 times 3, all the way up to 4 times n. So 4 times sigma k, and again here, you don't have any n or k to replace. So you cannot use a sigma, you just write down how many n, how many 1, how many 1. We have n equations, so of course n ones, okay? N over 1s. Now, just before we start the sigma k squared and the sigma k in previous lecture. Okay? So we will replace this one and that one by formula, and we have left only sigma k cube as an unknown value. Now, and on left side, you multiply out and simplify, then you will have that. And the right side, you replace with the formula for sigma k and sigma k squared. But this one you don't have any formula yet. That's why we have to leave. And then here, this is only a known expression. So moving all this one on the other side and simplify, okay? It means we solve for that, and this one come out eventually 1 times 1 plus 1 divided by 2 n squared. Over here you may notice n times n plus 1 divided by 2 is the same as what? It was a sigma. This one is sigma k. Okay? So in advanced mathematics contest, they make a question with sigma k cube equal sigma k itself whole expression square. Of course here from 1 through n, from 1 through n. I just skip, okay, for simplicity. This one is a very important relation. Sometimes they may use this one as a factoring problem in advanced math contest. Okay? Okay, keep in mind, n times n plus 1 divided by 2 whole value, you squared, and it will be same as sigma k cube. Sigma k cube, okay? This one. Okay, we studied how to derive sigma k squared and sigma k cube. Okay, by last time we studied the sigma k and the answer term and the k square, and today we added k cube. And then I give you one more formula of that. And also we will study how to derive that, even though very similar way, okay? Just like a longer work process, and that's it. Okay? But anyway, I give you formula. Try memorize. With those formula, if you want to practice more, you go to my website www.A.durkkim.com, practice test and algebra 2, and then you choose a series .pdf, and you have some more practice questions. Okay? Thank you. I will show you how to derive formula sigma k to the 4th power next time. Thank you. Bye.